What if the greatest breakthrough in computing power wasn't just faster chips, but a completely different universe of logic? Quantum computing isn't about doing what classical computers do, just faster. It's about doing what classical computers can't do at all. And here's the shocker. While most people think it's decades away, quantum technology is already disrupting industries quietly, right now. Let's separate the hype from the hard truth and reveal how quantum computing is changing business, money, and power in ways the headlines barely mention. In this episode, we'll decode the real economic and strategic impact of quantum computing. You'll learn why quantum breakthroughs could rewrite global finance, how corporations and countries are fighting for quantum supremacy, what it means for cybersecurity, AI, and investment strategies, and most importantly, when all this will actually matter for you. By the end, you'll understand not just the technology, but the psychology, timing, and economics of the next computing revolution. Let's dive in. For over half a century, the world has relied on Moore's law, the idea that computing power doubles every 2 years. That exponential march gave us smartphones, AI, and entire digital economies. But by the 2010s, silicon chips began hitting physical limits. Transistors couldn't shrink forever. The world needed a new paradigm. Enter quantum computing, a model that doesn't just process zeros and ones, but uses the strange physics of quantum mechanics, superposition, entanglement, and interference. A quantum bit, or qubit, can represent multiple states at once. Imagine reading every page of a book simultaneously instead of line by line. That's quantum logic. At first, it sounded impossible, but by 2019, Google announced it had achieved quantum supremacy, solving a problem that would have taken a supercomputer 10,000 years in 200 seconds. The catch? That problem wasn't useful. Yet it marked the beginning of something profound. The dawn of a new computing reality. Here's the problem. Hype always outruns capability. Every few years, headlines scream, "Quantum breakthrough," but real-world application seems to lag. Why? Because quantum computing is brutally difficult. Qubits are fragile. They lose their state when even a small vibration or temperature fluctuation occurs. Scientists call it decoherence, and it's like trying to balance a spinning coin on the head of a pin in a hurricane. Investors poured billions in, hoping for the next gold rush. Yet skeptics call it a mirage, fusion energy for computers. Still, something is changing beneath the surface. Quantum computing is slowly becoming practical, not as a consumer tool, but as an industrial weapon. Financial institutions like JP Chase and Goldman Sachs are already experimenting with quantum algorithms for risk modeling and portfolio optimization. Pharmaceutical companies like Roche and Pfizer use quantum simulations to accelerate drug discovery, testing molecular interactions at unprecedented precision. And in logistics, corporations like DHL and Volkswagen are using early-stage quantum solvers to optimize traffic and supply chains, saving millions in fuel and delivery time. So while the hype headlines scream quantum supremacy, the quiet truth is this: quantum advantage, when it actually makes real business sense, is already arriving. To understand why quantum computing matters, we need to zoom out. Human progress has always been limited by our ability to calculate. From abacuses to smartphones, computation is how civilization solves problems. But most problems in the real world, like predicting markets, designing materials, or managing logistics, are combinatorial explosions. The possible outcomes grow so fast that even supercomputers choke. Quantum computing attacks this limitation head-on. Instead of testing one scenario at a time, a quantum computer explores many simultaneously, collapsing them into the best solution through interference. For example, think of a financial market as a maze of trillions of possibilities. A classical computer walks every path. A quantum computer walks all of them at once and shows you the shortest exit. That's why experts say quantum computing could break modern encryption, optimize investment portfolios, and simulate the global economy with frightening speed. But there's also a philosophical layer. Quantum mechanics itself breaks our intuitive sense of cause and effect. It operates in probabilities, not certainties. In other words, the next wave of computation won't just change how we calculate. It'll change how we think about reality itself. Let's look at some real cases. Case 1. Finance, risk, arbitrage, and derivatives. J.P. Morgan's Quantum Lab built a prototype algorithm for Monte Carlo simulations, which banks use for risk analysis. Early results show potential to reduce computing time from hours to seconds. In high-frequency trading, where microseconds mean millions, that's game-changing. Case 2. Supply chain. Volkswagen's quantum traffic flow. Volkswagen partnered with D-Wave to test quantum optimization for taxi routes in Beijing. Using quantum annealing, they reduced average waiting time by up to 15%. Scale that across logistics networks, and you're talking billions in global efficiency. Case 3. Medicine. Quantum chemistry. Traditional computers approximate molecular behavior. Quantum computers can simulate it natively. Roche and IBM collaborated to model enzyme reactions for potential Alzheimer's drugs, something previously impossible at full accuracy. Case 4. Energy. Grid optimization. Quantum models are being tested for renewable energy balancing, ensuring wind, solar, and grid storage operate in harmony. Imagine cutting energy waste across an entire city just through better computation. Each of these use cases represents early-stage quantum advantage, not science fiction, but pilot reality. And here's the twist. The companies mastering quantum now will hold the same edge that early internet adopters had in the 1990s. Except this time, the stakes are trillions, not billions. So what can you do as a thinker, investor, or entrepreneur? 1. Educate yourself early. The first movers in every tech wave weren't the smartest. They were the most prepared. Start understanding quantum concepts, even at a basic level. 2. Follow the quantum economy. Watch how industries like finance, logistics, and materials science adapt. Where complexity lives, quantum opportunity follows. 3. Invest in infrastructure, not hype. The real value isn't in flashy startups promising quantum apps, but in the ecosystem. Cryogenics, error correction, cloud integration, and algorithm design. 4. Adopt a quantum mindset. Embrace paradox, probability, and systems thinking. Quantum computing isn't just a technology, it's a worldview. Because the leaders of the quantum age won't just code differently, they'll think differently. Let's be honest, most people won't notice when the quantum revolution happens. There won't be a big switch flipped, no fireworks, just a slow, silent takeover, the same way the internet crept into our lives one click at a time. But for those paying attention, for those learning, building, and thinking ahead, the future won't be a mystery. It'll be an opportunity. Because the real impact of quantum computing isn't about breaking encryption or making faster processors, it's about breaking old mindsets and computing entirely new possibilities. Thanks for watching. Stay curious, stay grounded, and as always, think exponentially. Subscribe for more weekly episodes that decode money, technology, and the hidden psychology of innovation.